Let's go ahead and talk about how to approximate probabilities using the empirical rule. This is going to help us get a rough estimate of the probabilities. The empirical rule can be used to help us approximate the area under a curve, and the empirical rule states the following. Approximately 60% of the data is within one standard deviation of the mean. Approximately 95% of the data is within two standard deviations away from the mean. And finally, approximately 99.7% of the data is within three standard deviations. I'm going to show you how that looks like using the curve we have below. Let me go ahead and emphasize that we should only use the empirical rule for a very rough estimate. We have more precise methods to compute the area under the curve. We're going to use our calculator. We're going to use Google Sheets. You can also use Excel. Let's use exercise number 2 to help you visualize the empirical rule. Here in exercise number 2, we are talking about a random variable that follows a normal distribution. So I'm already going to start writing x follows a normal distribution. The mean is 25 and the standard deviation is 3. So let me go ahead and write that here. X follows a normal distribution with a mean equal to 25 and a standard deviation equal to 3. So let's go ahead and label the mean at the center. And then we're also going to label the first standard deviation, second standard deviation, and third standard deviation on the left and right. Okay, so we have 25 at the center. The first standard deviation to the right is 28. Notice I'm just taking 25 plus 3. The second standard deviation to the right is going to be 31. Again, I'm adding another standard deviation. And then the third standard deviation here on the right is going to be 34. Now let's go ahead and label the standard deviations on the left. On the left, we have 22, marking the first standard deviation on the left. Then we have 19, which marks the second standard deviation on the left. And then 16, which marks the third standard deviation on the left. What is the empirical rule saying? The empirical rule says that there is 68% of the data values within one standard deviation of the mean. That means that between 22 and 28, we have 68% of the data values. Now, if we're talking about area, we will say that we have 0.68 of the area between 22 and 28. Now, the empirical rule says that 95% of the data is within two standard deviations. That means that if we look at all the data between 19 and 31, we have 95% of the data. The empirical rule says we have 99.7% within three standard deviations of the mean. That means that between 60 and 34 here, between the third standard deviation on the left and the third standard deviation on the right, between those values, we have 99.7% of the data. Now, it doesn't mean that we don't have any area below 16 and above 34. Right? We have some area there. Why? Because we know that the area under the whole curve is 1. Within 16 and 34, we only have 99.7% of the area. Again, there's more area here on the left. Okay, we're going to keep that in mind. Now, let me go back. Let me delete all the highlighting that I did. If you know that you have 68% of the data values between 22 and 28, would you be able to tell me what percent of the data values are between 22 and 25? Again, what percent do we have between 22 and 25? I hope your answer is yes, right? If we have 68% of the data values between 22 and 28, then we must have 34% between 22 and 25, and the other 34% is between 25 and 28. We can say this because of the symmetry of the graph. The area that we have between 22 and 25 is exactly the same as the area that we have between 25 and 28. If we know that the area between 22 and 28 is 68% of the area, then again, we have 34% and 34%. Now, would you be able to tell me the area between 19 and 22? What is this area? This one's a little bit harder. If you know that the area between 19 and 31 is 95%, would you be able to tell me the area between 19 and 22? To find this area, we're going to say, well, take 95% and subtract 68. That's going to give you 27. Now, this 27 here represents the area between 19 and 22 and the area between 28 and 31. That is what that 27 represents. If I want the area between 19 and 22, I need to divide 27. I need to divide it by 2. If I take 27 and I divide it by 2, I get 13.5%. That is the percent of data values that we have between 19 and 22. That means that we also have 13.5% of the data values between 28 and 31. And notice, if you take 13.5 plus 34 plus 34 plus 13.5, you get 95%, which is the area that we have between 19 and 31. What I'm trying to emphasize here is that the empirical rule, 68, 95, 99.7%, can help us find other percentages, such as that 13.5%, that 34. Now, I also want us to find the area between 16 and 19 and the area between 31 and 34. How are we going to do that? We know that the area between 16 and 34 is 99.7. Let's go ahead and subtract 95%. 95% is subtracting this area here in the middle. So 99.7% minus 95% is going to give us 4.7. Now, 4.7% is the area between 16 and 19 and between 31 and 34. If we go ahead and divide 4.7 by 2, we're going to get the area between 16 and 19. So again, take 4.7 and divide it by 2. That is going to give you 2.35%. That is the area that you have between 16 and 19. That is also the area that you have between 31 and 34. And notice, if you go ahead and take 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35, you're going to get 99.7%, which is the area that we have between 16 and 34. Now, would you be able to find the area here on the tail, or the percent of values that we have in that area, by saying, look, under the whole curve, we have 100% of the data values. Let's take 100% minus all of these percentages, or all of this area here. So here, we know that 99.7% of the data values are between 16 and 34. So we're subtracting this percentage. If we take 100 minus 99.7, we get 0.3. 0.3%. That percent is the area on the left-hand side of 16 and the area on the right side of 34. If we want the area to the left-hand side of 16, we need to take 0.3 and we need to divide it by 2. That is going to give us 0.15. That is the area that we have below 16. The area that we have above 16 is also 0.15. So again, let me erase here. I want to make sure that I give you a clean version of the curve. One thing to emphasize here is that if we add all the percentages here, we should get 100%. With this visual, now we can answer the questions below. Find the probability of x being between 22 and 28. To find this probability, you need to find the area between 22 and 28. Here you're going to use the percentages that we have. The area between 22 and 28, it was given to us by the empirical rule. We know that 68% of the data values are within those values. So here, this probability, you can think of the probability being equal to 0.68. That is the area between 22 and 28. But remember, probabilities can also be expressed as percentages. So here we could just say this probability is 68%, right? If we have 68% of all data values between 22 and 28, then the probability of a data value being between 22 and 28 is just that 68%. Now, would you be able to answer the following question? Find the probability of x being less than 25. 25 is the mean. How much area do you have to the left of this here is equal to 0.5. That is half of the area that is under the curve. Remember, the area under the curve is 1. half of the area is below the mean. So the probability of x being less than 25 is 0.5, which is equal to 50%. And now notice, if we look at the percentages that we have here, we would be adding 34% plus 13.5 plus 2.35 plus 0.15, and that is going to give us the 50%. Now I'm going to let you do part B, C, and E on your own. With the vision that we have, you should be able to answer those questions. Now, I'm going to ask you to give me those probabilities as a percentage. So again, keep that in mind. You're going to be providing a percent.